Hello. In this video, we are going to. This is the part 3 of a series of video that we have been doing regarding basically implementing um, some of the interesting algorithms around LLM, especially during inference time. So, in this part, on for this part, what we are going to do, we are going to implement a speculative decoding, but we are going to use Cursor as one tool, and we want to see if we instruct the Cursor, or essentially the LLM behind Cursor, with a bit more detailed prompt about how a speculative decoding algorithm works. Can Cursor in one shot implement the algo? How much Cursor can give us leverage in order to implement the algo, and how much work is left for us as a human in order to improve and then basically correct the algorithm. Keep in mind that this is the paper that we are going to implement. We have a implementation of this algorithm, which is for speculative decoding. There is algorithm description here. We already implemented this algorithm in this repository called Speculative Decoding. If you go to GitHub, K Jahan Speculative Decoding, there is basically a human implementation of that algorithm. But for this specific test, we want to see how much Cursor could help us to implement this from scratch. So without wasting more time, let's go to Cursor and then open this empty folder and then bring over our prompt. So our prompt, okay, let's bring our prompt and then I describe the prompt. So the prompt is this: write Python code, minimum necessary, or let's say necessary Python code for implementing the speculative decoding algorithm for LLM inference. Essentially, use two models, one being small as draft model, and one being a large model, a large LLM as the target model. Okay, generate K tokens using the draft model for a given user prompt, such as what is capital of France, or and then use the target model to evaluate and sample the tokens, okay, the final tokens. Essentially, we want to specifically we want to implement the method described in the paper, where we have P and Q for target and draft models probability for each speculated token, X. If P is greater than Q, then we accept X as a token, as a speculated token. Otherwise, we flipped a coin with probability of P head with probability of head being probability of head equal to P divided by Q, and accept the token, the token X if we see a head. Okay, if we reject the token and we still have more tokens left for evaluation, we sample we sample the last token using distribution and exit. make sure you test your code with the prompt. And okay, prompt, don't write unnecessary code, add a readme as well as the requirements. Make sure that your logic is correct. Okay, so let's do this. So let's, okay. Okay, so it's writing it right now. So we already see the requirement.txt. We are seeing a speculative decoding file. One that I'm thinking is that if we have some kind of, if behind the scene Cursor is using my previous implementation, if those previous implementation has been somehow cached or stored in a vector DB, is it leveraging the memory? But we will see. So here, this is essentially the speculative decoding. A quick glance, it seems that, okay, so it has this class. So what it does, it has a main, it's using GPT-2 as the draft model, target model, GPT-2 medium. And then what it's doing is kind of call that class capital of France, and then what it does, decoder speculative decode, so the main prompt, and then okay, and then the speculative decode, which is this method. It tokens the input, it goes through max number of tokens, it has the draft tokens and draft probabilities. So it goes through the input IDs, which are the input tokens, and for K tokens, interesting, it basically sample from the draft. It samples from distribution, and it gets next probabilities. Let's look at get next probabilities. Is this essentially is a model? Okay, no grad makes sense. It just get the outputs, it gets the logics, and then pass the softmax. This seems correct. Sample from distribution should be very trivial. Okay, this seems correct. So you have a property distribution and you need one sample, so it basically is a torch function. If I quickly look at the torch function, so you have a multinomial, you have distribution over tokens, and you just a tensor where each row contains sample. So in this is sample from the multinomial property distribution located in the corresponding. Okay. Let me see. So these are the weights, and then from that weight, so essentially you sample. Okay. So essentially, for K, speculative token is kept sampling from that using the draft model, and then when it's done with that, let's see how it accepted tokens or the algo has been evaluated target model. Okay, so it goes through the draft tokens and probabilities, and then it calls the target probability. Okay, so uses the target model. One thing that I don't understand is that why it's not giving all of the draft tokens at once. This is kind of a bug. When it's kind of passing the prompt, the new prompt, which is the base prompt, plus the proposed tokens from the draft tokens. I'm not sure why you need a for loop, and then in this for loop is basically giving one token at a time and just keep evaluating. This is kind of not necessary. So it seems basically syntactically or kind of semantically followed my steps to some extent, but it gets the target probability, the draft probability. If it compared them, if P is greater than Q, it accepts it, otherwise it comes here. Flip a coin. If that's again is head, then it accepts the draft token, otherwise it's coming. And then target probability minus draft probability means 0, it clamped it. And then okay, this part seems fine, and then it break. But one thing that I think there is a bug here is that this part of the logic, I don't understand why it has to do this. Because what essentially we have to do is that we take all of the draft token proposal, we append it to our main prompt, and then we just pass it to the target probability, the target model, in order to get all likelihoods of the proposed tokens. So now we have all P's, and then we can go through the loop, and then for each token in the speculated token, we just pull their P and their Q from the target model, the Q from the draft model, and then just do the evaluation. So this part is not correct, but this is the implementation that essentially Cursor had. So if I want to wrap it up, is that yes, so it got the 70% of the logic correct, but there is some details here that a human has to come and review it, and then basically make sure that the logic has been implemented correctly. So we still need the human in the loop for at least this kind of tasks, when more heavy algo implementation and verification is needed. Thank you. I will see you in the next video. I'm going to have more demos and use cases using Cursor or other tools to see again the limitation of LLMs while coding or refactoring code, or kind of implementing new algorithms with nuances, or kind of other use cases. We are going to do that, and then as an exercise, so that gives us hopefully more insights that what are the capabilities and limitations